All right, so I put 5 problems on the board to review before we start the applications of logs. And the first one I want to talk about here is, surprisingly enough, number 1. And it was log base 3 of 1/3. And I hope that right away you thought, I can just write that as 3 to the negative 1, because then the answer is right there. The answer is negative 1. Raise your hand if you had negative 1. Good. Now, that'll be in the middle of some other problem. See, like, what if it would have been like 7 times that minus x is equal to 12? Oh, that would be really confusing. No, it wouldn't, because as soon as you figured out that all of this was just negative 1, then that makes this negative 7 minus x equals 12. And then you just solve it from there. It'd be really easy. You can take a big complicated part of the problem and just replace it with a negative 1. All right. Question number 2 that was written on the board before we started was log base 3 of x minus log base 3 of 5. And are the bases the same? Yes. Then you can combine them together and make it just log base 3 of x over 5. If you said 5x, you were wrong. This is a minus, so it's x over 5. All right. Can we get the door in the back? Carlos, can you shut the door, please? Oh, that'll work too, Kellen. Thank you. All right, number 3. Number 3 is log base a of b is equal to c. You should have known enough to go, he means this. A to the c equals b. That's how you can simplify that, and it's not a log anymore. All right, it's an exponential. The next one, number 4, is log base 5 of n plus log base 5 of 3. And right there, I know I'm going to add those together, because if you have 2 logs, you should always make them into 1 log. But it goes on, and it says equals log base 5 of 15. Well, these two combine into log base 5 of 3n, and then I have the log with the same base on both sides. And if the bases are the same, the answer's already there. 3n must equal 15, n equals 5. Who had n equals 5 on that one? Sweet. And then the last one was just, do you remember how to solve a quadratic? And the first thing you should do is not add 3x to both sides. Man, a ton of kids think that. And then they think they're going to square root to get out of this. And it won't work. Quadratics have to be set equal to 0. So you subtract 4 from both sides. And you got x squared minus 3x minus 4 equals 0. And then my favorite saying, if you can factor it, you should. X and plus and minus. And this will be minus 4 and plus 1. Double checking that and that. Make a total of negative 3x. Yay. So x equals negative 1 and x equals 4. Did any of you even think about whether maybe you should check that? Now, I know you're probably thinking, well, I did everything right. The problem is that this problem probably would have started with a log. And if you go stick this in and it ends up going in the base or the argument and making the base negative, do you get how that would be a problem? So another reminder, you're in a high enough level class now, halfway through Algebra 2, that sometimes we start getting extraneous answers. Is it a guarantee that that's extraneous? No, but it's worth checking. And you stick it back in the original problem, you see if it worked. And if it makes the original problem have a negative base, then that's not possible. Or a negative argument, that's not possible. And then if it had, you'd go like this. Again, it is not automatically extraneous just because it's negative. But it's worth checking both answers. All right, so we are ready to move on to the new stuff. So everybody go to page 2 of the slides. Here's the theme for today. Be with me. On every problem today, you get a big log formula and you stick a number in. That's it. That's what you're doing today. You're sticking a number into this formula. So on that first one, it says find the slope of the beach if the average diameter of the sand is 0.25 millimeters. So I'm going to stick that 0.25 somewhere. And even one of my smartest students last hour walked up and was like, I'm confused, because she was trying to do all of this in her head. You got to write the formula out trust me, it will work way better if you do. And where do I put this? This said it was the diameter, so it's probably D. D in millimeters is the diameter. Okay, so then I'm going to put the 0.25 in where the D was, which is right there. So I'm going to put the 0.25, and remember, this is the argument. I'm putting in a parenthesis. Goes right there. Now, this brings up an important point. Do you get this is probably something you'd want a calculator for? That's why I said to take out your calculator. Now, one more thing. We decided to take the easy problems from the beginning of this unit that would be so easy that a calculator could make them into a useless question. And we're going to put variables into those so that you'll have a calculator on this test, but it won't help you do the incredibly easy ones. Like, for example, let's say that you have a calculator on the test, but the problem says A log base m of p equals r. Do you get that the calculator can't solve that for you at all? Because you can't put that in a calculator. You can't put all the variables in there. Whereas if we had told you that this was 8 and this was 2 and this was 3, you could do this in your head if you're really good, or you could just use a calculator, type it all in, you'd have the answer. See what I mean? So we're going to have variables in some of your problems that kind of foils using the calculator on everything. But you'll need the calculator for things like this. And that brings up an important point. Log base 10 is easy because there's a button for that. Look on your calculator right now. Find the button that's called log. You might notice that it doesn't have a base, and it doesn't even ask you for a base. If you type the log button, you are saying log base 10. Is there a way to change the base? Yes, but right now, we don't need to change the base, and I'll show you how to change the base in a sec. So how do you get this? You type exactly what you see right here. In fact, I would type the whole thing circled in yellow. And let's start typing together. 0.118. Now, do you have to say times? No. If you just put it right next to the next thing, which is log, it'll know you mean times. 0.118 log. There's a log button. Do you see it to the left of the 7 key? It's on the left side. 0.118 log. You don't have to type the base 10. It knows it's base 10. 0.25. Enter. Did you get negative 0.07104? Okay, then you're doing it right. If you did not, there's always a kid. So I'm going to make sure you get this. It should say negative 0.07104 ... Okay, if you didn't get that, type it in again. Now we just have to add that. So go ahead and take a second and do that. Plus 0.159. And I got my answer. And if you don't write out the formula, you don't know what you have. You just have this weird decimal, 0.087. I have no idea what that is. 0.0, change colors, 0.0879, which I could probably round to 0.88. It doesn't tell me where to round, so I kind of get latitude of where I could round to. So I'm going to pick 0.088. What is it? It's S. I can go look and figure out what that is, and it's sand. No, S is slope. It's slope. Because if you don't know, it says in the problem, the slope S. Oh, it's the slope of the beach. If you're like, that doesn't look like any slope I'm used to. I'm used to slopes like, rise over run. Well, let me show you what that would be. This would be like 8 over 100. It's actually 88 over 1,000. That's what that is. So just to make you understand, this is like a really flat slope. It's a really small slope. It's like it rises 88 feet, but it runs 1,000 feet. You aren't going to be expected to interpret it. My point is just when you have this answer and you come up with this, what is that? You can look at the problem to know what you just found. I found the slope, and it's 0.088. If you really want to understand it better, here's what slope look like. A very flat slope means it barely goes up. It's like that. And it rises 88 when it runs 1,000. way to shrink that down to be it rises 8 when it runs 100. So it rises 0.8 if you go 10. So it's only rising a tiny bit. So that's the slope of the beach. All right, and then of course they'll have you do it backwards. What do you mean? Well, it says now that it has a slope of 0.125. So you're going to put that right here. And if you solve it down and you actually write all of this out and you actually solve it, which we're not going to do right now to save time. At the end, you get it'll say D equals, and you'll know, oh, I'm solving for the diameter. I'm going to get how big the sand particles are. All right, what's important here is, do you know what to do first? So my question, and that I want you to talk with the kid next to you about, is looking at this equation right here that I'm underlining in red. What's the first step? And then what would the second step be? Don't do it. Just talk about what would you do first, and then what would you do second. Hint, you want to solve for the log and get it alone. So what's the first step? What's the second step? Talk to the kid next to you.
You would just minus it, 0.15.
Calculator broken issue. Got that handled. All right, here we go. You should have told the kid next to you that you would subtract this 0.159 first and then divide by the 0.118. All right, we good with that? Okay, then you'd have something like this. Some decimal. Did anybody actually do it? Negative point something. I can't remember. What'd you get?
Negative 0.2881.
0.288. Let's call it 288 because I can't fit anymore. Then how would you finish it? Talk to the kid next to you. What's the next step? What do you do now? Talk to the kid next to you. All right, you should hopefully have been talking about doing the circle of logs. 10 to the power of that equals that. All right, cool. Now let's move on. That was about the slope of a beach, and I want you to really understand this. If you go to a beach and it is a very steep beach, like in the background of this picture, you see a beach that I found on the internet that is super steep. It is only because of how big the sand particles are. That's why it's so steep. It didn't have to do with the wind or the waves last night. Irrelevant. It really is. It's how steep that'll be is based on how big the sand particles are. And the bigger they are, the steeper the beach is. So in Hawaii, for example, they have a lot of beaches that have very big sand. It's almost like little tiny rocks. And those beaches are very steep. In Florida, they have a lot of beaches that are white, sandy, powdery, super fine. It's almost like dust. Those beaches are very flat. They don't go steep into the ocean. They go flat into the ocean. All right, next slide, please. I made these slides because I really like this unit because it's very real world. You've heard of decibels, haven't you? Something incredibly quiet. Like you might hear like a fly. Sometimes they scratch their wings together. You could actually hear that if you were close enough and it was incredibly quiet. That would be like one of those tiny, tiny decibels things that you could hear, or even a whisper. And of course, you can whisper so quiet that you could barely hear it. I feel like it doesn't qualify as a whisper anymore if you can't actually hear it. So those kind of are, variable, but they do say a number here for it. Where would you put this number? Well, you got to decide. It's either I or D. And if you put it in the wrong spot, you'll get it wrong. Take a second, read the problem, and theorize to the person next to you. Where do you think you put it?
Yeah.
It is I, and it's not too hard. It's intensity. So it would go here. And it would be kind of a pain to put in the calculator, but you can all type 5.4 times 10 to the power of negative 10. There's a faster way. It would be 5.4 EE. There's an EE key on the calculator. And then you divide it by this. And then you take log base 10 of that. Remember, that's just the log button. The log button is log base 10. Take a second, type that all in. It won't take too long. Then do log of it, and then times it by 10. The last thing I would do is this. I would do this part that I'm circling in green first. And then I would do log of that. Type it in. Do it. 5.4. And you can do EE is the fast way. Negative 10. If you want to do it the slow way, just to know for sure you're doing it right, 5.4 times 10. Powered up. The little caret thing. Negative 10. I hope you figured out that it comes out to just 10 times log base 10 of 5.4. And again, to type this in the calculator, it's super easy because it's log base 10, so you use the log button, log 5.4. And then you take that and times it by 10. Did you end up with 7.3? Raise your hand if you got 7.3. All right, I got 7.3. I got a bunch of people that got 7.3. All right, and I get it's complicated to type these in, so maybe you just typed it in wrong. Don't worry too much about scientific notation. It is something you're supposed to know, but I know you could type this in a pinch on your calculator. All right, so let's go to another thing that uses logs in the formula, besides the decibels. This one is how pH or like how acidic or basic something is. Do you guys know what's exactly in the middle of the scale? 7 is correct. Very good. 7 is neutral, like water. You can pour water on you. It doesn't hurt you a bit because it's neutral. And water, you can drink it, and it's obviously good for you, and it's neutral. But if you drink something that's incredibly acidic, it could incredibly hurt you. Like there's some acids that would melt your tongue off, and there's other acids that are just taste good. Evidence, Coke. It's used by tons of people around the world, incredibly popular beverage worldwide, and it's very acidic. And if you left a tooth in there, why would you do that? Well, just to show people how acidic it is, you can take a baby tooth, put it in a glass of Coke, leave it overnight, the tooth will be mostly gone by the morning. It literally melts down teeth. That's why the dentist says don't drink pop. It's true. You're basically washing your teeth with acid when you drink pop. And I do when it drives me crazy. I wish I could quit, but so don't start the Coke, kids. I mean Coca-Cola, just to clarify. And the other kind's bad too. But anyways, so alkalinity of a substance. This is log base 10 of what the heck is H plus? You'd have to look in the problem. I don't know. Let's see what it says. Oh, where H plus is the hydrogen ion concentration. All right, so here's an H plus of 0.0003, and you're going to put it right there. So go ahead and do that. Negative. I would put the negative in first. Negative. I'd use the minus key at the very bottom. It says not a minus, it's a negative. It's at the very bottom row. Not the one up in the plus minus times, you know. Okay, so negative log. You don't type base 10, it knows that. And then it's 0.0003. Did you get 3.5-ish? Raise your hand if you did. Okay, cool. What did we just figure out? Well, 7's neutral. We just figured out that apple juice is about a 3.5. Do you get that's on the acidic side of the scale? All right, just so you know, pop is even more acidic than that. And we humans definitely like that acidic flavor. I can't think of a single thing that we drink that's on the basic side of the scale. In fact, if you drank bleach, it would kill you. Okay, and it's an 11. It's a very not basic. What's the other thing called? Or sorry. It's not acidic. It's basic. Right? Have I got that right? You science nerds out there? Awesome. So, bleach, you could stick the value of 11 where? Well, it's telling you the pH value. See? So I know to put it here. Now, take just a second, and I want to know, I know some of you are not going to know what to do. With this problem, what would be the first step? Talk to the kid next to you. What's the first step? Yes, divide by the negative first. That's a really good catch. I know some of you were like, do the rewrite, the circle of logs thing. No. You have to get rid of the negative first. Now the negative gets divided off by dividing by -1 on both sides. And of course, now you got -11 equals log, I'm going to write it here, base 10 of H plus. That's just a funny looking variable. Now is the time you'd rewrite it and go 10 to the -11th, a ridiculously small number, equals H plus. And you've got H plus sitting right there, so you know what you've got. You solved for this. That's what you have at the end. That's why you leave the variables in your problem when you're doing the problem, and you know what it is at the end. Oh, I guess I just found H plus. All right, moving on. This is a typical problem, and I want you to notice the theme. Look, they gave me an equation. I'm going to stick the numbers in it. Let's not even do this one. It would be too easy. This is where you'd put the time, which is defined here. T is the number of years after 2011. That's kind of an important thing to know what T is. Or P, which is what? The entire world population. Moving on to the next problem. Bacterial colony. I would jump right to this. Then I go look at the problem and go, what do they want? Where T is the number of hours since the experiment started. Okay, T is the hours. That's right there. That's the hours. And C must be something. I guess I can look back at the thing and go, what's the C? Oh, it's the colony population. All right, so this is the population given a certain amount of time. And then I'd take my 3,000 and I'd figure out, what's that? Does it feel like a time? No. So then it probably feels like it's the C of T. Kind of like f of x. I'd put the 3,000 there. There's the whole challenge for all these problems is stick the number in the right spot and then solve. Okay. We have homework and it looks like this. Everybody find this worksheet and then we'll do the first problem together. We are leading up to the test on Friday and we still have today's plus tomorrow's new stuff. Then Thursday's the review, Friday's the test. The good part about this test is that the cumulative comes right after it. So if you did have a trouble on this Friday's test, right away by Wednesday of the following week, you get your second try. All right, so here we go. If my memory serves, we're going to do problems 1 and 2 and 6 through 7. Okay, good. So then you guys go ahead and cross off 3 and 4 and number 5 also, which is something on the next page, but I think you get the idea. And here we go on number 1. Here's my formula. Figure out where to stick the 60. Then solve it. Pro tip. Actually write it out. On some of these, sure, it'll end up being easy enough that you can do it by just typing it in the calculator. But if you put it antler spread, is that A or H? I don't know. I got to look it up. Because antler spread doesn't, it could be A. I don't know. I better look. Yep, antler spread is A. So 60 goes here. Okay, honestly, on this one, I would just type all that in the calculator. I'd just write the 60 there, so I showed some work. And then I'd know I got H at the end. And I'd type all this in, and I got my answer. But for the next one, I'd bring it down. I put it in the wrong spot already, so just copy the formula, Mr. Server. Okay, now I got to put my 63 in the right spot. 63 inches high at the shoulder. Oh, that's the H. So the 63 goes here. And I'm going to solve this. All right. I'm going to add 176. Then I'll divide by 116 next. The last thing I'll do is the circle of logs. And there's my hints for you. At the end, I will have A, and you should be able to look up in the directions. What the heck do I have? A is the antler spread. And you'll be finding the antler spread. All right, one last thing. I promise you, you need to know this. Stop, look up. Whenever everybody's looking up. I know you're broken out of the problem for a second. Look up for a second. Still waiting for 2 people. Don't make me say your names. Thank you. All right, wait, look up, Charlie. Okay, listen. You will have to type in something with a different base than 10, and you need to know how. How in the heck do you type that in? I can do this one in my head because 8 is 2 to the 3rd, so I know the answer is 3, right? But how would I type it in? Do you know? Because you'll have to. Because that one I know, you could do in your head. But what if it's log base 2 of, let's make it one you can't do in your head then. Log base 2 of 9. Do you know how to put that in? Because you'll have to. All right. See, it's base 2. That's the problem. You can't hit the log button. That's base 10. So here's how you do it. Everybody try this right now. Log 9 and then hit enter divided by log 2. Again, you need to hit enter after saying the log 9. Otherwise, you're in the middle of your log and you're typing the divide by. So log 9, enter, then divide by log 2. And you'll get a decimal. Would you please compare it to the kid next to you and we'll see if you've got the same thing. Log 9, divide by log 2. Remember, it's log 9, enter, and divided by log 2. Did you get 0.3169? Raise your hand if you got 0.3169. Good. Now, you want to know the faster way? Some of you guys have newer calculators that you can do this faster. This is one of those moments where some of you are going to realize, oh crap, my calculator's not as good. Hit this series math button, then alpha button, then math. Math, alpha, math. You'll see a little log with the boxes that pop up. If you don't see this log with the boxes that pop up, you got the old calculator and you have to do it this way. It's not that hard, but you either have the new calculator or you don't. Yes,
I got 3.16 instead of
I think that's the correct answer.
Oh,
All right. So, did you get log with the little boxes? Raise your hand if you got the log with the little boxes. Okay, that's like 2/3 of you. So it's like 1/3 of you have the old calculator. It's the way it goes. It's okay. It'll still work. You just have to type log 9 over log 2. All right. But if I had the new calculator like 2/3 of you do, I'd do it that way. Math alpha math. And then you can just type the little numbers in the boxes and you get the same answer you got before. Okay, cool. Now you know everything. And you have a worksheet, you have a bunch of time. I hope you come up and ask me questions. And that's all I got for the video for today.